In this lesson, we're going to look at some, we'll call them problems. So it kind of takes what we've learned and applies them to questions that are not quite so straightforward. All right, let's look at the first one. A piano teacher and her students are having a group photograph taken. There are 3 boys and 5 girls. The photographer wants the boys to sit together and the girls to sit together for one of the poses. How many ways can the students and teachers sit in a row of 9 chairs? All right, if there were no conditions, if we just had the 9 chairs, this would be 9 factorial. Okay? But that's not going to work here because there are some conditions. Okay, I'm going to put 9 chairs just to give us some visual help here. Oops, how many is that? 4, 5, 6, 7, 8. No, just 9. Okay, the photographer wants the boys to sit together. So there are 3 boys that are going to sit together. I'm just going to draw this in. Boy, boy, boy. Okay, and they have to be together. Then there are 5 girls. Girl, 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 girl. And they have to be together. All right, and then you're left with the teacher. So this would be one possible way that they could sit. But we need to figure out all the possible ways. Okay? Whenever you have sitting together, so I'm going to put this in quotation marks, sit together or group together or whatever, I always think of tying them in together and making them one item. Okay, so let's consider this. If the boys are one item and the girls are one item and the teacher, really there's 3 factorial ways to rearrange these 3 groups. Okay, but the boys can switch places because these are not identical objects. 3 boys are not 3 identical twins. They are, or triplets. They're different. So I have to rearrange the boys. Same with the girls. The girls are 5 different girls, so I have to rearrange the 5 girls. All right, and this is how to group this in this condition, in this situation. So I'm going to get 6 times 120 is 4,320 ways they could be grouped. All right, next one. Next question, a combination problem. They're common in computer science. Suppose there is a set of 10 different data items represented by these letters, and they're supposed to be placed into 4 different memory cells in a computer. Only 3 data items are placed into the first cell. Okay, so here's the first cell. And we're taking 3 out of the 10. So it doesn't matter what order I put them in, so I'm going to go 10, choose 3. Okay? And what about the next cell? Okay, so the second cell, what am I supposed to put in there? Okay, 4 items go in the second cell. Is it 10, choose 4? Well, it's not, right? Because I've already used 3 of the 10. For example, let's say you took A, B, and C and said I'm putting them in the first cell. This gives me only 7 data items, and I have to choose 4 of them. Okay, and then what? This is the third cell. I'm supposed to put 3 items in there. The last 3, because I've already placed 3 in here. I've placed 4 in here. That means there are only 3 more to choose from. And if I choose 3 out of 3, that's actually no choice. There's only one way to do that. Okay, so to do this question, 10, choose 3 is 120. 7, choose 4 is 35. And 3, choose 3 is 1. So there are 4,200 ways to place the cells. Okay, last example. How many different 5-card hands? Okay, so I just like to give myself a visual. 5-card hands that contain at most one black. At most one. Okay, so if here we see a picture of 1. Could there be 2 black cards? No. Could there be no black cards? Yes. So we have 2 situations to consider. 1 black card or no black card. Okay, because it says at most 1. So 0 or 1 would both be okay. Alright, if I want to put 1 black card, how many ways can I pick 1 black card? That's 26, choose 1. Right, there are 26 black cards in the deck, and I'm going to choose 1. And I have to choose 4 red ones. So there are 26 red ones to choose. I'm going to choose 4 of them. Or, which is a plus sign, how do I do 0 black? Well, you could say 26 choose 0. 26 choose 0 is just 1. So multiplying by 1 won't change anything. What we want to know is how many ways can you choose 5 from 26 red. Okay, so if you want to make yourself some notes here, this is the black, this is the red, this is the black, this is the red. Okay, 26 choose 1. There's 26 ways to do that. 26 choose 4. Oh, there's quite a few ways to do this. 26 choose 0 is 1. And 26 choose 5. So this is going to be 26 times 14,950. So, yeah, there's quite a few possibilities. By the way, this is one of the things that makes poker quite a difficult game to play. It's because there are just so many ways to have a different hand. So I don't know if you ever played a card game where you just think, oh, I need that 10 of spades or that 5 of hearts. I just need that one card, but I'm going to get it. Well, the chances of getting the card that you want is not great. I mean, look at the number of possible ways you can rearrange just this situation. There's just so many possibilities. All right, homework. Okay, and let's make sure that's it. There's also some questions here in the notes. Well, I guess not so much questions. They're down here. What page is that? I guess that's page 31. Okay. So in the notes here, page 31. So you can do that too.